Quantum Science and Physics, Deep Dive with Entertainment. Opening hook, 0 o'clock to 1:30. Start with an engaging, exciting question. Imagine you're holding an object, like a coin. Now, picture this: that coin, at the tiniest level, is both heads and tails at the same time. You can't see it, but it's happening. Crazy, right? This is just a hint of what happens in the bizarre world of quantum mechanics. The universe at the quantum scale is like nothing you've ever imagined. Welcome to the weird, wacky, and utterly mind-blowing world of quantum science. Ready to dive in? Quick overview: today, we're going to uncover some strange truths. We'll explore quantum entanglement, superposition, the bizarre behavior of particles, quantum computing, and even dive into time travel. It's a journey that'll make your mind question reality itself. Let's go. 1. What is quantum mechanics? 1:30 to 3 o'clock. Quick pop culture reference. You've probably heard about quantum mechanics in movies like Interstellar or Avengers: Endgame. But what's actually going on when we talk about quantum mechanics? Start with basics. Quantum mechanics is the science of the infinitesimally small, the subatomic particles that make up everything in the universe, from electrons and photons to quarks. Fun fact: these particles don't play by our regular rules. In fact, they break all the rules of classical physics. It's like a cosmic game where the rules change every time you look. Now, the mind-bending part. In quantum mechanics, particles can exist in multiple states at the same time. Think about it. A particle can be both here and there at once. Mind blown. 2. Wave-particle duality, 3 o'clock to 5 o'clock. Entertaining example: let's play a game. You've got a ball, and you throw it at a wall. The ball bounces off because it's a solid object. Now imagine if you threw a ball that wasn't just a ball, but a wave too. What would happen? It could pass through the wall, then spread out like a ripple in water. But wait, how does this work? Quantum phenomenon. Enter wave-particle duality. In quantum mechanics, particles like electrons or photons behave both as particles and waves at the same time. The famous double-slit experiment shows this. When electrons are fired at a wall through two slits, they create an interference pattern, just like waves on water. But when you try to observe them, they act like particles, creating two clear lines instead of waves. Why is this important? It means observation changes reality. The act of looking at something makes it behave differently. So, the universe literally changes based on our perceptions. 3. Superposition, 5 o'clock to 7 o'clock. Engaging metaphor: picture a coin spinning in the air. It's in a state of superposition, it's both heads and tails at the same time. But the moment it lands, it's either heads or tails. Superposition is exactly this, but with quantum particles. Quantum particles can exist in multiple states simultaneously. Real-world example: imagine a quantum computer. Unlike a regular computer that uses bits, 0 or 1, a quantum computer uses qubits, 0 and 1 at the same time. These qubits are in superposition, allowing quantum computers to process enormous amounts of data simultaneously, solving problems that would take regular computers millions of years to complete. Mind-bending part: if this is too crazy to comprehend, don't worry, our brains are not wired to understand quantum reality. It's a whole new dimension of weirdness. 4. Quantum entanglement, 7 o'clock to 9 o'clock. Entertaining story: imagine you and your best friend are both given a pair of magic dice. You roll them, but there's a twist: no matter how far apart you are, when you look at your dice, your friend's dice instantly show the exact same result. It's as if your dice are entangled. Real explanation: This is quantum entanglement. When two quantum particles become entangled, they instantly influence each other, even if they are light years apart. This spooky action was so strange that even Einstein called it spooky action at a distance. Why does it matter? Quantum entanglement is key to the future of quantum computing and quantum cryptography. It's the basis of secure quantum communication, where any attempt to eavesdrop on a message will disrupt the entanglement, alerting the sender and receiver. 5. Quantum computing, 9 o'clock to 11 o'clock. Set the stage. Imagine a computer that can solve problems in minutes that would take our supercomputers millions of years. Sounds like science fiction. Well, it's becoming a reality, thanks to quantum computing. Explaining qubits in a fun way: in a classical computer, a bit is either 0 or 1, like a simple switch. But in quantum computing, qubits can be both 0 and 1, allowing for massive parallel computation. Key applications: drug discovery. Quantum computers can simulate molecular interactions and discover new drugs that would take decades using classical computers. Cybersecurity. Quantum cryptography will make hacking nearly impossible by using the laws of quantum mechanics to create unbreakable encryption. Fun example: quantum computers are like the multitasking superheroes of the tech world. They can handle way more than your regular computer can. 6. Time travel and quantum physics, 11 o'clock to 12:30. Entertaining scenario: what if I told you that quantum physics might make time travel possible? Would you be ready to pack up and jump to the future, or past? Explaining wormholes and time travel. Wormholes are like shortcuts in spacetime. These theoretical tunnels could connect distant parts of the universe or even different points in time. If quantum mechanics can stabilize them, we might just have a theoretical time machine on our hands. Fun fact: you could technically send information into the past using quantum entanglement. But don't pack your bags for time travel just yet. Scientists are still figuring out how to manipulate spacetime. 7. Quantum holography, 1230 to 1400 hours. Start with a mind-bending question: what if I told you that our 3D universe might just be a hologram, projected onto the surface of a 2D plane? Explain the quantum holographic principle. According to the holographic principle, all the information in the universe is encoded on a 2D surface, just like a hologram. This radical theory emerged from studying black holes and the nature of gravity. Why it's mind-blowing: if true, this theory suggests that our reality, everything we experience, might be an illusion, just like a 3D hologram created from 2D information. Conclusion and call to action: 1400 hours to 1500 hours. Wrap up. Quantum science is not just mind-boggling, it's the foundation of future technologies. From the futuristic quantum computers to time travel theories, quantum mechanics is shaping the future in ways we can barely imagine. Engage your audience. So, what do you think? Are we living in a hologram? Do you believe quantum time travel could be possible? Drop your thoughts in the comments, and don't forget to subscribe for more mind-blowing content from the world of quantum mechanics.